Are we alone? This question has echoed through the corridors of human history, sparking curiosity and wonder. From the earliest civilizations to modern times, humanity has always been fascinated by the night sky. People have been asking this question for a very long time. Ancient astronomers, with their rudimentary tools, mapped the heavens and speculated about the existence of other worlds. They pondered whether those distant points of light were suns like our own, perhaps with their own planets and inhabitants. For thousands of years, we've looked up at the stars and wondered if anyone else is looking back. The vastness of the cosmos has always been a source of inspiration and mystery. Each star a potential sun, each sun a potential home to life. We really want to know if there are other living things out there. The idea that we might not be alone in the universe is both thrilling and humbling. It challenges our understanding of life and our place in the cosmos. Maybe they're smarter than us. Perhaps they have advanced civilizations, with technologies far beyond our own. They might have already solved the mysteries of the universe that we are just beginning to explore. Maybe they're just starting out. The universe is huge. It spans billions of light years, with countless galaxies, each containing billions of stars. The sheer scale of it is almost incomprehensible. It has billions and billions of stars, each one a potential beacon of life. The more we learn about the universe, the more we realize how little we know. Every discovery opens up new questions and possibilities. Lots of these stars have planets going around them. These exoplanets, as we call them, come in all shapes and sizes. Some are rocky like Earth, others are gas giants like Jupiter. Some are in the habitable zone, where conditions might be just right for life. It's hard to believe that Earth is the only place with life. Our planet is teeming with diverse forms of life, from the deepest oceans to the highest mountains. If life can thrive in such extreme conditions here, why not elsewhere? The universe is just too big. The more we explore, the more we find that the conditions for life might not be as rare as we once thought. There are countless planets and moons that could potentially harbor life, but we haven't found proof yet. Despite our best efforts, the evidence of extraterrestrial life remains elusive. We have sent probes to distant planets, listened for signals from the stars, and scanned the skies with powerful telescopes. So the search goes on. We continue to look, to listen, and to wonder. The quest to find out if we are alone in the universe is one of the greatest adventures of our time. And who knows? Maybe one day we will find the answer. The Fermi paradox is a confusing idea. Named after the physicist Enrico Fermi, it questions why, given the vastness and age of the universe, we haven't encountered any signs of extraterrestrial civilizations. With billions of stars in our galaxy alone, many of which have planets in the habitable zone, the silence is perplexing. The universe is old and huge. It's been around for about 13.8 billion years, and our galaxy, the Milky Way, is just one of an estimated 2 trillion galaxies. Each of these galaxies contains millions or even billions of stars, many of which could host planets with conditions suitable for life. The sheer scale and age of the universe make the absence of contact even more mysterious. If life is everywhere, shouldn't we have met aliens by now? Where is everyone? This question becomes even more pressing when we consider the possibility of advanced civilizations that could have developed interstellar travel. With so many opportunities for life to arise and evolve, the lack of evidence for extraterrestrial intelligence is baffling. One idea is the Great Filter. This concept suggests that there is a stage in the development of life that is extremely difficult to surpass. It could be a biological, technological, or environmental hurdle that prevents civilizations from reaching a point where they can communicate or travel across the stars. This says that life faces many challenges to become advanced enough to travel in space. These challenges could be numerous and varied, ranging from the initial formation of life to the development of complex organisms, and eventually intelligent beings capable of creating advanced technology. These challenges could be anything from big rocks hitting planets to civilizations destroying themselves. Natural disasters like asteroid impacts, supervolcanoes, or gamma-ray bursts could wipe out life before it has a chance to thrive. Alternatively, intelligent civilizations might self-destruct through nuclear war, environmental collapse, or other catastrophic events. Maybe most life doesn't live long enough to contact others. The great filter could be behind us, meaning we've already passed the most difficult hurdles, or it could be ahead of us, suggesting that our future holds significant challenges that we have yet to overcome. Another idea is that smart aliens choose to stay hidden. Maybe they're watching us. This hypothesis, known as the zoo hypothesis, suggests that advanced extraterrestrial civilizations intentionally avoid contact with us to allow for natural evolution and sociocultural development, much like zookeepers try not to disturb the animals in their care. Maybe they don't want to talk to us. They might see us as too primitive or dangerous, or they could have ethical reasons for not interfering with our development. Alternatively, they might be waiting for us to reach a certain level of technological or social maturity before initiating contact. It's a strange thought that we might not be alone, but are being ignored on purpose. The idea that advanced civilizations are out there, silently observing us, adds a layer of mystery and intrigue to our quest for knowledge. As we continue to explore the cosmos, we may one day uncover the truth behind the silence of the stars. We often look for aliens that are like us. We look for things that are smart, use technology, and want to talk. But what if life is totally different? Life on other planets might be made of different stuff. It might live in places that would kill us. We need to think about life in new ways. We should be ready to find things that are completely different from anything we know. Maybe there are living things made of pure energy. Maybe there are things that can travel through time and space. Anything is possible. We need to be ready for surprises. The universe is unbelievably big. It's hard to understand how big. Some scientists think it might go on forever. This makes it seem very likely that there's life somewhere else. If the universe never ends, Earth can't be the only place with life. That would be impossible. But because the universe is so big, it's hard to find life. Even if there are many other civilizations, they are very, very far away. Our messages might never reach them, and theirs might never reach us. Section 5. Looking for smart aliens. Simple life might be common, but smart life is probably rare. SETI, the search for extraterrestrial intelligence, looks for aliens who can communicate. SETI scientists use big dishes to listen for signals from space. They look for patterns that show someone is sending the signals. So far, we haven't found anything for sure. Finding smart aliens would be a huge deal. It would change how we see ourselves in the universe. We would have to accept that we are not alone, and other smart beings might have answers to our biggest questions. Section 6. Guessing the chances. When we look up at the night sky, it's easy to feel a sense of wonder and curiosity. Are we alone in this vast universe? Or is there someone out there looking back at us? The Drake equation is a famous math problem. It was formulated by Dr. Frank Drake in 1961, and it serves as a framework for estimating the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. It tries to guess how many alien civilizations we can talk to in our galaxy. The equation takes into account several factors that are crucial for the development of intelligent life. It looks at things like how many stars are born, how many of those stars have planetary systems, and how many of those planets could potentially support life. How many stars have planets, and how many of those planets are in the habitable zone, where conditions might be just right for life to exist. And how often life gets smart. It also considers the fraction of planets where intelligent life evolves, and the length of time such civilizations can communicate. The Drake equation helps us think about alien life, and it provides a scientific basis for the search for extraterrestrial intelligence, or SETI. But we don't know the answers to many of the questions in it. Many of the variables in the equation are still unknown, and our estimates are based on limited data. We can't guess very well yet. However, as our technology and understanding of the universe improve, we are getting closer to finding some of these answers. But new discoveries make us hopeful. Every new exoplanet discovered, every new piece of data collected brings us one step closer to understanding our place in the cosmos. We now know that planets are very common in the Milky Way. In fact, there are likely more planets than stars in our galaxy. Many of these planets are the right distance from their stars for life like ours. These so-called habitable zone planets have the potential to host liquid water, a key ingredient for life as we know it. The search continues, and with each discovery we get a little closer to answering the age-old question: are we alone in the universe? Section 7. New planets, new ideas. Finding planets around other stars has changed everything. Using telescopes like Kepler and TESS, scientists have found thousands of planets around other stars. These planets are all different. Some are huge balls of gas bigger than Jupiter, some are rocky like Earth, some are very close to their stars, others are far away. All these different planets show us that our solar system might not be normal. It makes us think differently about what a normal group of planets looks like. Section 8. Amazing tools. The search for alien life is always changing. We have new technology all the time, giving us better ways to look at space. New telescopes like the James Webb Space Telescope let us study the air around other planets. We can look for things that show there might be life, like oxygen or methane. As our technology gets better, we will discover even more amazing things. Searching for alien life shows how creative humans are and how curious we are. Section 9. Where do we fit in? Looking for alien life is more than just science. It makes us think about our place in the universe. If we are alone, life is very special, and we need to protect it. But if we are not alone, that opens up so many possibilities. It means we are part of something much bigger, and our journey of discovery is just beginning.